We're a team, JDF 2354, and our project is the CS 1301 tutoring system. Our project, the Intelligent CS 1301 tutoring system, was proposed by Professor Rodrigo Barella, who is a CS 1301 professor at Georgia Tech, for our intended users, CS 1301 students and instructors. Currently, CS 1301 students may need extra help or practice with programming concepts, but office hour lines can take too long, which can deter them from going. Additionally, other learning platforms such as iExcel, Gradescope, and Learning Point don't allow students to get personalized practice on these CS concepts. CS 1301 students also, in Gradescope, which is a platform currently being used, are unable to view which lines of code they need to fix. Instead, they just see whether their code is completely correct. CS instructors similarly want their students to be able to get interactive feedback so they can understand concepts in the long run. Additionally, CS instructors want to be able to see the topics students have trouble with, instead of just seeing a final submission so that they can adjust their lesson plans. For our research, we did user research and research using existing literature. For user research, which we got from our clients' experience with the class, we found out that students don't have to have prior experience with coding or Gradescope before taking the class. In fact, instructors even offer tutorials for Gradescope. There's a diversity of majors taking the course, as every Georgia Tech student is required to take an Intro to Computing class, but CS, ECE, Ivan Allen College students are required to take CS 1301, while other majors take CS 1315 or 1371. From existing literature, we found that it's valuable to have strict separation between student and instructor views for database security, and running code locally is safer from a security perspective than server-side.
In addition to the previously mentioned capacity and compatibility restraints, we also need to make sure that our site is compatible with all modern computer internet browsers. It should remain online 24/7, although short downtime to perform maintenance would be acceptable. We should make sure that we are securely storing question and answer data such that it is not lost in the case of an outage, but backup servers are hard to justify. To assist in maintaining the site, we will properly document all of our code, and we plan on implementing a way to add questions without changes to the code itself. The site should be able to handle a load of all current GT students at the same time, as the load may increase as students study for finals. Each submission should be processed in 5 to 10 seconds, as longer processing times are likely to lead to a loss in motivation of the student. Finally, as mentioned previously, we must remain fully in compliance with FERPA, so all student data, including submissions, must be strongly encrypted.
Our system architecture most closely resembles the model view controller design pattern, where our models are the MySQL database and response processing model. The view is the question web page, and the controllers are the backend and the Python shell. The communication between each part is shown in the diagram here. For our technology stack, our backend uses Node.js, which is required for the Plesk servers. We will need to use Georgia Tech web hosting and Express. The front end of our coded artifact uses Jade, while our future project will use React. The database will use MySQL, and some packages to use will be JS-Python interpreter and Python shell to interpret any Python input.
In regards to our prototype, we see on the right our non-coded Figma artifact that simulates the student's experience. This includes the single sign-on for students to log in, a user interface where students can submit Python code, and a home page to navigate to the topic list in order to select one question to practice and answer. So for our coded artifact, we created a front-end portion of the student's question response page. Some of the reasons for implementing these features in our artifact are: the first being we wanted our backend to talk to our front end. This being student types his or her answer into the text box, and our backend links the program. The second reason, we wanted to start from the student's view of the application before extending it to the instructor's view, and that is why we implemented these resources first, as seen in the prototype.
All right, so this is a brief demonstration of our artifact. As you can see, this is sort of the code side, the back end. And if we go and enter the app, it will actually show us this question screen that we modeled out previously in that prototype. It's a little lower quality, but it has the functionality. So if I type in print and then I give it hello world, I can actually give it some obvious clear error to have the Python compiling correctly, and it will tell me that I got an indentation error, and it'll give me the option to practice or just continue testing. This is something that we found is that if we just force students to actually go and practice immediately, people get very annoyed. So we're giving the option to practice and the option to just continue submitting to test. Next, we have the print hello world. This one is just incorrect. It's not doing the exclamation mark, so you can see that it tells me that I got the typos wrong. And if I add an exclamation mark and I test that, then it'll show me all the different incorrect responses I got and then the correct response I got. And I have the option to go to the next question. And all of this is being communicated to the backend. As you can see, the different requests are getting sent. So you can see every time that I'm submitting with this post request. And that's it for our artifact. In terms of the lessons that we learned through the development of this artifact and all the prototyping that went into it, a lot of what we learned was related to accepting feedback. So we actually spent a lot of time thinking about what it is that we got and then how to actually implement that in terms of actually getting it into the design. And the next big thing, and this sort of ties into that, is our tech stack, which was really heavily limited by those integration criteria and the ability for us to actually, make our code work the way we want it to. So we're sort of forced into using Node because of the fact we need to run on Plus servers. And we're sort of, forced to set up our program a certain way because we want to deploy it for 200 or so students to access it, right? And so we sort of have these technical constraints that sort of taught us a lot in sort of the setup of this project. The last thing, and this is I think the most important, is setting time to work together. We had a lot of issues with scheduling. 6 people trying to coordinate schedules, some of us working jobs, is very, very difficult. And so we learned a lot about actually, finding times when we could meet. And I feel like that was really, really valuable. In the future, now that we sort of have this student question response screen set up where you can actually input student responses, we're going to work on building up the instructor side of it. So an instructor question input screen, so that you can actually create the questions and put those in there. And alongside that, we want to build out the system for organizing those questions into either this one is a practice question for if you get this part of this other question wrong, right? So we want to build that system up as well. After that will come analytics, right? But that's further down the line. Another core piece of our system is authentication. We want to make sure that student responses are secure and that that it's only professors that can see the professor side. Next up is GT server hosting. We want to get this hosted on GT servers basically as soon as we possibly can, and so that's going to come alongside authentication. And once we sort of have the core system down, we'd really like to enforce the visual consistency that we had within our prototyping to the actual web-coded artifact. And that's sort of it for the first steps that we're going to take going into next semester.